and if you are giving it 2.2 volts it will have this amount, and as you can see it is linear over the entire range, and you won't have any problem with that. And as you can see, that is why my circuit is linear. It is because I replaced this resistor with a current source, and that is how I accomplish my voltage controlled pulse width modulation with very good linearity. So, and as I told you, this circuit is a monostable, and the reason because it works is because you have to force the unstable state with some kind of external signal, and that is why the datasheet states that when the timer is connected, blah blah blah, with a continuous pulse train. So this circuit works because it needs a external triggering provided by some oscillator circuit that gives these conditions, and that external oscillator will fix the frequency at which your modulator works. And the way that I achieve that is configuring this same integrated circuit, but in the Astable operation with some change that I will show you. Okay, so this is my design, and this is how I achieve all the constraints for this design, for this voltage controlled pulse width modulator. And as you can see here, this is the datasheet circuit, and I am using a LED to see the output, to see the change in the brightness, and this integrated circuit over there is just it is a current source, and you can select the current of that current source just with one resistor, and that's it pretty much. And as you can see, this other part of the circuit is my oscillator. For the pulse train, we need a pulse train of that kind. We need someone like this one. It goes to 0 from, it goes to 0 for not very long, just some microseconds or so, and I achieved that using another 555. And as you may know, this circuit is doing this square wave, and I will show you how it works in another video blog, but the time that this square wave is in the low state depends just on this resistor, and if you make that resistor very small in comparison with the other one, you will have a square wave which its high period is nothing. It's a pulse, it's a low pulse. So that is how I achieve that requirement. I will show you how to configure, how to use the 555 in the Astable operation, in the square wave oscillator operation. And I just added a potentiometer to control this circuit, to modulate the output, and that is how I have done this circuit, and that is pretty much everything. Okay, how I did the calculations. First, you need to think what frequency do you need for this oscillator, And when you have your frequency, you have your period, and just remember that the period is the inverse, the frequency is the inverse of the period, and that is all. And your circuit will need the capacitor to charge from 0 volts to the maximum control voltage, just to the maximum control voltage, and it will have to do it in the time t. So if you are going to use for your maximum control voltage, let's say 5 volts, then you will have to replace in this equation here 5 volts, and then you will have to replace here, you have to choose your capacitor, let's say 100 nanofarads, and then your time, your period, the time that takes to a complete cycle of that signal. And in my case it was 0.1 millisecond, and because that my current is 5 milliamps. So, and that is how you have to calculate this current source for this circuit to work. And notice that if you are giving this circuit a control voltage of, let's say, 3 volts, the time that this circuit is going to be in the high state is from 0 to 3 volts, and it will take, you just have to replace here the values, and you will have the time that this circuit stay in the high state. And then after the period, the incoming pulse for your modulator will reset the capacitor, and another cycle will start again, and it will repeat indefinitely, and that is how you achieve the modulation, and that's how it works. And for your pulse generator, you just have to calc the RA, because you have to choose RB. Here you have RB and RA. You just have to choose RB to be let's say 100 times less than 100 times less, or maybe 50 times less than RA, and you just have to choose C, and that is pretty much all, because if you choose C and RB is 50 times less than RA, you have all the variables for calculating RA, and you just have to build this circuit, this Astable circuit with these values, and then you will have the train pulse required for driving this modulator, and your circuit is going to work very nicely. And here you can see the circuit working, and I'm powering it up with 5 volts using my homemade power supply. Let's show you how the brightness of this LED changes with the power modulation, pulse width modulation. I'm going to turn out the lights so you can see the effect better. And now I'm going to show you that with the oscilloscope. Okay, I am using my computer and as an oscilloscope with a a crap USB oscilloscope that I have around. Sorry, because I don't have a digital storage oscilloscope here. So as you can see, if I change the potentiometer, I'm changing the control voltage, and because that I'm changing the duty cycle of this signal. So let's try. Okay. As you can see, my circuit works very well, and I hope you enjoyed this demonstration and all the stuff on it. And if you have any questions about my circuit or about anything, just tell me and I will do a video blog about that. So thank you very much for watching.